audio is working, we've got sound, we've got video. All right, so let us get right into it. So welcome guys, third tutorial. For the three of you that are here. No worries, I'll teach if there's three or none, we'll still do a tutorial. So this week we're going to be focusing on the assignment 2 that most of you hopefully maybe at least take a look at or open it up or something like that. And we're going to be focusing on unitary gates and how we can transfer a function into unitary gates. So before I get started, any questions about the assignment? I'm going to do an example, but any questions like formatting, anything like that off the top of your head?
Yeah.
Sure.
Do we have to use the template that you think of?
No, not at all. Like if you find something else that you find much more like reasonable and it's still using unitary gates, I absolutely suggest it. Yeah. Was that a general question or did you have a template?
General.
Okay. Yeah, no, absolutely, yeah.
I'm not sure if I'm understanding this assignment wrong, but this fun to math is just you can use it like it's general, right? Like
yeah.
I can use it the same function to do every single problem.
Pretty much, yeah. This assignment is extremely straightforward, and that it should pretty much be function to mat, like cookie cutter code, like every single place.
Yeah, so you just change the function that you're passing to function to matter.
Absolutely, yeah. It's very straightforward in that. The only one that's going to be a little bit tricky is well, like obviously the ones that are going to be straightforward where you just pass in the function. The next, like the only one that might be a little bit tricky is the reverse one, because that you have to write a certain kind of function to do a reverse. But other than that, it's still essentially just the same thing. It's converting it into a gate. So yeah. So, but yes, in that way, this that's kind of why Dr. Sabri made it only do a week later, is because it's pretty straightforward. Even though it is 5 questions, it hopefully should be quick enough for you guys to go through. So sure.
Problem 3 kind of cuts off, but I'm assuming it says explain why it failed.
Yes, it fails. Sorry, yeah, it does cut off, and he did say that. Yes, problem 3. So this specifically would fail, and you need to try and think about exactly why it would fail.
Okay.
Yeah, exactly. Yeah, sorry, that should be a correction in there. I'll to make a note.
To talk about why it failed. Like, I think I have an idea of why, but like
Okay.
I'm not sure what things.
Sure. I mean, you can discuss it. I won't tell you whether it's right or wrong, but like if you want to put a shot to like your fellow students.
If you guys did the assignment,
Looked at it.
I did the first part.
just like the question, what
The X, CCS.
Oh wait, what we're supposed to zoom out?
No, you don't have to do this XCCX, but if you want to as a starting example, you can. Yeah, it's not necessary.
Did you
Okay. I mean, you could throw out and try and explain an answer if you want to, and like just explain the process.
My only explanation was like if you do all the other ones,
Mhm.
what I noticed is so you're gonna get numbers between basically 1 and 7 or 8, I think.
Okay.
And all the other ones you always get a unique number every single time you run it for all the inputs 1, 2, 3, 4, 5, 6, 7.
Right.
You get a unique number, so the gate's like reversible.
Okay.
From my understanding.
Yeah.
When I'm doing problem 3, I pick number and n equals 3 again.
Yeah.
And in that case, I believe when you do input 0, you're going to get 0.
Yeah.
Then you do input 1, you'll get 4. Input 2, you'll get 0 because it'll be 8. Mod 8, it'll be 0 again. So it's not reversible. So I don't know if that would break the gate. Like he always says that gates have to be reversible, right? But I don't know if that's what's the cause that it's failing.
Right. So basically, you're saying because like in the function here, let's throw it into Excel real quick. So basically, I'll put this right here. When you have like say x is here, and then whatever your output is here, it's going to be like x times 4, and then all that in mod. Yeah. Excel's got pretty much everything. Excel's Turing complete and got lots of stuff. So I like to use it just for short illustrative. Oh, I did. Is that not what we're supposed to? Oh, it's x times 4. You're right. X times 4. So that times 4. So we should be able to test it with that. That should be mod 4. Yeah. So yeah.
I think if you loop that around to like 3 would be also 4.
Yeah. So if it's n equals 3, then we've got up to what, 7, right? Or 0 to 7. Sorry, I'll throw in a 0 there.
Yeah. So it repeats like 0, 4, 0, 4, which is not reversible.
Yeah. So that goes up to 7.
But I have no clue what like he says it fails construction. Like,
Yeah.
Is it something internally? Is it like what's causing failure?
Right. Yeah. One of the things you could do if you really wanted to is you could try constructing out the matrix and seeing like the matrix that this outputs in the. You remember when he was going through the examples of like how to create the matrix and to see what it produces. But yeah, this definitely is weird behavior that it like, yeah, there's multiple numbers and there's not a unique number that repeats over. So
Yeah, also what I was going to figure out is, I guess like I know 4 doesn't cause it not to work, but like what's the main reason behind it? Is it because 4 is a multiple of 2n? Is it because 4 just happens to be too big?
well, if you, yeah, the actual reasoning behind that. Well, if you think about it, yeah, it possibly, like, because we're doing modulo, we're just doing clock arithmetic, right? So like you're saying, if something does pour over when there's modulo arithmetic, then you're going to start to get repeats of values, and then you won't have a unique answer for each, like a one-to-one correspondence, essentially. So that could be part of it. But yeah, no, it's an interesting point, because yeah, it is definitely the function in here that adds the most to them. But then in that case, why doesn't the x times 3 fail and instead of the x times 4?
X times 3 was just kind of like the sweet spot or what?
Right. But yeah, that is definitely the heart of the problem. So you're on the right track. I will tell you that. So yeah. All right. Okay. Let's yeah, great questions though. Absolutely. And for everyone else, let's just get into a quick example. You could follow it at home, so I'll keep it nice and short and sweet. But yeah, let's start with the example that was actually given and go through there, make it in Qiskit real quick, and then we'll answer anything else based on that. So yeah, let's do the standard imports and everything. I'm just going to copy paste this from the slides, as I usually do. Throw that in there, make sure it imports. Then I'm going to do our generate circuit, which is always pretty useful. Does anyone have any questions about the generate circuit? I'm assuming most people copy it from the template, but if you do, like if there's anything that you don't follow or anything like that, let me know. You don't really need to understand how it goes, but you know it's Python. You can parse it if you want to. It's just making a for loop of the zeros and ones, so it's pretty straightforward. I say that, but I don't mean to. If you do have questions, please do ask. So then we go on to our actual function 2 matrix here. So this one can be a little bit more difficult to parse, just because it's using like these list comprehensions here. So it's a little bit more difficult to understand what is actually going on. So we can copy that in and actually go through that a little bit more if you want. So this is we're working off of obviously Dr. Sabri's code here. And what he's trying to set up here is basically making a list comprehension so that each line will essentially put a 0 or 1 based on what the actual function is doing. So here we have a like R in there as one of our variables. I'm assuming hopefully everyone is familiar with list comprehensions, at least a little bit in Python. So here what we're doing is we're translating the truth value in this little statement here of the function at our actual value and seeing if it's equal to R, and if it is, then it transfers it into a 0 or 1. That's converting it from Boolean value into an int value. And then it iterates through the actual range of the dimension, which, you know, it's going to be 0, 1, 2, 3, 4, if dimension's 5, et cetera, et cetera. And then since it's in another loop, it does a nested loop in there. So that's how we're getting an actual matrix of lists. So lists of lists, 2-dimensional matrix, pretty good to go from there. And then it's just filling it out with each of the values if it Boolean matches. So what that function is doing there, you could write it other ways if you wanted to, but this is just his straightforward way to make an actual matrix really quickly. Oh, this should be indented, sorry. And then, yes, that should work. Then now we're going to have our actual like input circuit fragments here in the next line. So one is going to be measurement, which is pretty straightforward. We're just going to measure all the lines, so that shouldn't be anything hopefully new to anyone. We'll throw that in there. Put that in there. Next one. And then the circuit fragment for input. So this one might also get a little bit tricky if you're trying to actually read and understand what is going on here. So I'll put this out and then we'll go from there. So here we have our values that are going to be input, and you're going to see where this is going to get called later. But vals is one of our inputs here, and then we're going to do a length. So if n equals 3, then it's, you know, we're going to do vals of 3, and then it's going to go in. Oh, that should be a for loop in there. Sorry. Yes, and then if barrier, shouldn't that be indented? Sorry, 1 second. For IDX and it's indent. Yeah, that G barrier is outside that, so it creates it like that. But here for this for loop that he's doing, where you're putting all the x, one of the things to notice is he's kind of indexing it in reverse. So the for loop, it's the IDX is the iteration value, and then he's got a list comprehension to go through all the vowels in the enumerated list. So here he's doing n-1, and that's basically because in this circuit, if you think about it, if it's like Q0, Q1, Q2, you have to like order it in reverse. It's got to do Q2, Q1, Q0. So he's kind of like reverse going through a for loop from like the end to the beginning, so that it just goes in reverse. So that's what's going there. It can be a little bit tricky if you're trying to like think about it. Okay, like n minus that instead of just iteration, but hopefully that makes a little bit of sense. So I'll put a little comment here. Iterating in reverse to get ordering of circuit correct.
Brendan, would
Yes.
it be wrong then if we didn't have n minus idx and we just had idx?
If you made sure that you were like calling the right bits in the right way and then you reversed everything else, it would make sense. But then it might get a little bit tricky with you making sure that like that everything else matches up. It's just kind of the way that the circuit gets set up that it is that way. So if you index in the other way and made sure to index everything else in reverse, you can do that. But I think it's just easier to index in reverse using this one when you're actually putting in the inputs. But yeah, it would totally work if everything else was in the opposite way.
So this is just like a general way of how we used to say if this specific input was 1, flip it.
Mm-hmm.
So it's like a general code for that.
Yeah, pretty much. Yeah, it's a general way of like I said, Q_0, Q_1, and it's just kind of like the convention from Qiskit is that like if we have Q0, 1, 2, if we pass in a 0, 1, 1, that would say that instead of like, oh, sorry, I got the actual 0, 1, 1 there. It would instead of like you want it to pass in 0, 1, 1 here, but it would do it the opposite way. It would do 1, 1, 0, which is not exactly what we want. We want the least significant bit in the different order than it actually would pass in. So we kind of got to like reverse it. So yeah, but yeah, you could write it passing it in, but then make sure you'd have to flip this logic here and flip the actual lines of the circuits. So so yeah, that is the actual input little code there. And then we'll get on to our actual example circuit. So again, this is just going to be a function that we're going to call here for each of the circuits. So in this one, we're going to do a actual successor. So that's just when I have x plus 1 modulo the amount of input, or the n. So I'm going to copy this in here. So this is, everything is just in a function. So I indent that out. And then that should be our function setup. So yeah, as Chris pointed out, and as you guys have maybe seen, the main part of every piece of code here, and mostly the only thing that's changing, is this function in there. If you can see, it's the x plus 1 modulo 2 to the power n, and that's always going to be basically the function that we're going to change. And then from there, the actual function to mat will convert it into a matrix, and then later on we're going to pass it into a unitary circuit. Well, actually, sorry, it is being passed into a unitary circuit here, and that's where the Qiskit function takes it. After you made a quantum circuit, and takes it and turns into that unitary gate that we're going to see in just a second after we actually put an output. And then actually we can test it here. So we'll see that we're going to return the actual circuit G here and then the measurement of G. And to actually test it, we're going to iterate it by setting all those values through, and then it should output it in Qiskit. So, in Jupyter-lab. So do that, and then indent the full. Oh, I just copy pasted the same thing. Example circuits. There's our tests. Go through there. And now this should work. So I'm just going to run through all of these, make sure they run each other. Oh, did that run a error? I got an indentation error. Is that because this is supposed to be here? It shouldn't be. I thought the white space worked like that. Oh, never mind. I guess it makes a difference. Then run through all of these, and then run the test, and that will hold for a second. Oh, what did we get here? Traceback error. Function to mat is not defined. I thought I just did it up here. Oh, I'm still getting an indentation error.
I think you just need to indent the string.
This one here?
Maybe the big string.
Yeah.
Oh, it counts for comments as well. I thought it just didn't care because the white space. Great catch. Okay, thank you very much. I did not know that Python cared about that. Okay, good to know. All right, and then we have our actual output there. So we can see for our first example for the circuit, there is no X gates in there. So then we have G of 0. So 0 is our input in base 10, and then we're going to output of 1 in base 10 after our circuit, which is essentially our function, which is we're just going to, when we add just 1 modulo 8. So x 0 plus 1 modulo 8 is still 1 because there's no divisor, then we're good to go. And then it iterates through there. We keep adding 2, 3, 4, 5, 6, then 7, and then once it gets to 7, it's plus 1, so that becomes 8, and because of modulo 8, it's 0. So now we've fully flipped back around. So all the values are essentially unique in there, as Chris had pointed out about most of these. So we can essentially make circuits that create anything from any kind of function as long as the function itself that we put in there is reversible. Any questions on that example? It's pretty straightforward, I know, so I just want to make sure. So now let's do another quick one, just to show that pretty much you can plop in any other function in there. I had another one in my tutorial, or another example. Where was it here? Oh yes, I did another simple adding circuit where I did a function of, we'll do f of x, x plus 6 modulo 2 to the n. So I can plop that in, and it should be pretty much the exact same thing. I'm sure you all believe me, but just in case you don't. So I just replaced that little section there, and I use the exact same test code, except I call the function plus 6 mod, which I defined in my other example, plus 6 mod there, to define the actual function circuit. So we'll copy this in there, and put that in there. And now if I run it to define my function, and then run it to test it, it outputs everything, except now everything is plus 6. So the unitary circuit there is giving plus 6. So 0 is 6, then 7, and then since it overflows to 8, the modulo makes it 0, and then it's going to count up from there all the way to 4, 5. So yeah, that is pretty much, let me see if I have anything else in the tutorial. Yeah, that pretty much covers it. So very short tutorial this week. I know, I'm sorry, that was just it's a very straightforward assignment, and I don't want anything else on top of the assignment, and I know you guys are very busy as well. So that pretty much covers what you need to do for the assignment. And yeah, if you guys have any other questions, please feel free to ask. But that is pretty straightforward this week. So, barring that, oh yes, sorry, Chris.
Question, one, it's just like, I guess, a logical.
Sure.
Logistical question. So how do you say like 4 is like, I guess, it's not a multiple, but it's something like 2 to the power of, it's like,
I mean, you could call it like 4. Yeah, I mean, you could call it multiple because it's like power of n. It's like, because yeah, like, you know, power of something is just like we're multiplying it a bunch. So yeah, you could say it's like an interval of like n or something like that. Yeah.
and then the second question is for problem 4, where does the bitwise operator?
Yes. Ah, that's right. I forgot about problem 4. Problem 4 is also a little bit different.
So does the bitwise operator, or does the mod come first? So like, is it x, then it does the bitwise on the 2 to the power and stuff, and then does the mod on all of that?
Right, like the order of operations.
Like, I just put it in Python, I just put that whole line in,
Right.
and it just does it, and I'm assuming it works, but I also assumed that it did the bitwise operators. I didn't track it. I'm not sure what way it's supposed to be.
That is a great question. I do not know what the order of operations for a bitwise operator is, bitwise XOR. I'm assuming you might actually have to like the actual like Python itself, because it's like an X, it's like an OR, and I don't know the precedence calls of OR versus math when you're evaluating an expression in Python. I can ask Dr. Sabri about that, but I'm sure if you just typed it in like that, and like you said, if it works, it works. But
Yeah,
that's
it's
a question to
I
bring up.
wasn't sure if it worked, because when I was writing out like what the answer should be, I did the bitwise operator first.
Right.
So if I'm not sure, maybe it's the same both ways anyways. I don't
Right.
know, but I'm assuming just from looking at it, but
I mean, yeah, if it's an
there's no explicit brackets and specifying which is which, so
yeah.
I just kind of wrote it in. I hope.
I'm going to assume that it takes precedence over modulo, just because I think the way that if it is like a general expression, generally, actually I don't want to say this, but at least in some other languages, things associate to the left, so it would be like this expression and then this expression if you were to break it up. But I don't know if those are implicit in the way that Python does it. So that is a great question. Yeah, we should be explicit though. Yeah, I'll ask him in lecture just to be sure. Maybe he doesn't even know it if it's, as long as you follow that expression, it's the question, so that works. Yeah. And if anyone does get confused between converting between bits and like actual unitary numbers, it can get a little bit in there because like essentially if you have n equals 3, you have a 2 to the 3, so 8 different possibilities, and that makes an 8 by 8 matrix. It does get a little bit tricky if you ever do have to do the matrix by hand. Well, not tricky, but just you have to enumerate a lot of different possibilities. So there is different packages in Python you can use matrix multiplication, like NumPy, which I think is already built in. Do we import NumPy anywhere? Yeah, we do. So not saying you have to do this for your assignment, but you could if you didn't want to actually like make those matrices yourself. You could make it in NumPy, generate the outcomes, and then like actually show the matrices if you want to for your own justification and stuff like that. But that's obviously extra. No need to do that for this assignment. So.
I'm looking up the order of precedence for C.
Okay.
And modulo goes before bitwise XOR.
Oh.
So it's not too, but
So
it's weird because I did it on paper. Maybe I'm doing it somewhere wrong, but I got the right answer, or at least the answers in the top. So maybe it doesn't matter. Maybe it works both ways. I'm not sure.
Yeah, I mean, we could try putting it like on like parentheses and like parentheses here or parentheses there and saying, but yeah, if you're saying modulo has higher precedence, then this should be the correct like set of parentheses where it evaluates there. Interesting. Okay. I would think it would make a difference, but I don't know. Yeah, I don't want to actually do the question because then I'm doing your homework, but like that's something you guys could try just to see which one's which. So yeah, that's a great question though. I did not even think about that. You can ask about that. Anything else, or else I'll stop the recording. Obviously, you guys are welcome to stick around for as long as you want to. I'll be here. So.
For the dimensions, you did like 2 to the power of n.
Yes.
Like 0 and 1, right? Like the different combinations of 0.
Pretty much, yeah, exactly. Just because there's, because it's three lines, 3 to the power, 3 possibilities. Yeah, absolutely. Yeah, so it goes to 0. The other interesting to think about is like, yeah, what would happen at this circuit if we had different combinations or a different amount of circuits? And I'll also in the lecture make sure Dr. Sabri knows that we make sure it fails and test it with n equals 3, because with different n's, it might be a different order of like a different modulo that you're applying it to, so you might get a different answer. So I'm making sure that it's explicit that it's 3 there in that case, because the rest of them are 3. So yeah. Alrighty. Okay. Well, I will stop the recording and upload that. So thank you guys very much for coming. But obviously, you're welcome to stay as long as you need, or have any questions or anything like that. But I will let you get on with your days. Thank you very much.